Now we'll discuss here the demonstration of distance weighted KNN algorithm. Also, we will compare the result of weighted distance KNN algorithm with the general KNN algorithm. So here import all the required packages first. And execute your code. So Panda and NumPy we have imported here. Then load your data set and divide your data set into X and Y variable. Now my data set I am using here the K data set that is given in the syllabus. Right, my name of the data set is K data that I have uploaded here. My K data is uploaded in the home. This is my K data set here that now I am using here. So if you execute this code, right, you will find here. See, student, in the Python print function is optional, but when we execute the single line with the without print function, it works. But when there are set of lines, then you need to use the print function. Now I want to display here dataset.head. What is there in my dataset? So if you display here dataset variable, right, you will find that my dataset contains X and Y variable of our data set given in the data, problem statement, and class label is positive and negative. So how many records are there in my data set? 6 data points are there, and that we discussed in the previous session. There are 2 blue points and 4 orange points, right? So here my 4 negative samples are there and 2 positive samples are there. If you see here X data set, right? If you see here X data set, you will find only input features are there, that is X and Y points. We have fetched into the X variable with the help of iloc method. Again, we are using here -1 to exclude the class label. And if you see here Y variable, it has only the target labels. So negative, negative, positive, these are my target values, respective target values for all the records in my X variable, right? So only without colon -1 will give you this target value into the Y variable. I hope, student, you are clear with the data set. Now we will execute the Sklearn method. So here is the code for my KNN classifier. Right, so first you can import the library, that is K neighbors classifier, from this sklearn.neighbors package. Then you create the object of this. So again, my classifier is the name of my object, right? And then my number of neighbors are 3 here, right? So instead of 3, what is given in the problem statement? Neighbors are 3. Okay, so we can pass this neighbor in the problem statement. Also, my value of K is 3, so that I am passing here, right? Then you can fit the model for this given X and Y data set, this X and Y data set. So you can run this code, right? Then here this message indicate what we have built our KNN classifier model for the 3 values of the neighbors successfully. Right, then once your model is ready, you can use this model to predict the class of new query. So now my query point is what? 6, that is given in the problem statement itself, right? So you can copy, means execute this method. So xtest is my query point, right? For that we have used the np.array method. So 6,6. So if you run this, you will find it is executed successfully. And if you display this xtest, you will find the 6 values in that array, 6,6. Now you can pass this query to the predict function. So why predict variable will have the predicted value of this. So here Y predict is my user defined variable, right? So we are passing this query point x6 to the predict function of this classifier. It will predict this and we want to print this. So print function will print the output of the general KNN classifier method. So if you run this code, right, you will find here my general KNN method has predicted the class label negative for this given query point. Right, now we'll discuss here the distance weighted KNN classifier, right? The distance weighted KNN classifier, you no need to implement the code for the calculating the inverse distance, then for calculating the sum of all the inverse distance, and then dividing this sum from the each distance, right? Inverse distance. So here actually inbuilt parameter is there, that is weights equal to distance, that you can pass as another. While creating the object of this classifier, you can pass this second parameter. In the first general method only we pass the number of neighbors, but here in the weighted distance classifier you pass the one more parameter, that is weights. Again this spelling is inbuilt parameter, weights equal to distance. So this will create the object of this weighted distance KNN, and that you can pass to feed the model. So I will execute this code here. So if you run this, your weighted distance KNN classifier is executed successfully here. Then you can predict the class of your new query as usual, your general KNN by using the predict method. So here only my predicted class is using weighted distance. Weighted distance KNN prediction is here, right? So again my weighted distance KNN is predicting the negative class. See student, when my data set is very small, right? Now we have only calculated here the class of this query 66. You can try another samples also, right? So instead of instead of passing the x test as a 6 here, I want to pass here what? The whole data set. My whole data set is stored in which variable? That is x variable, right? So, and my y contains their respective class label, right? So if you pass here x as a testing data set, complete x array, we will see what is the result of this y prediction, right? So here, instead of x test, right, I want to pass what? Complete x data set. Then you can see the effect of distance weighted KNN, right? So here I am passing what? Complete x data set. So you can execute this method. So if you observe for this x data set, x is my whole data set. So for first data point, my predicted class is negative. For second also negative. For third it is positive, negative, negative, positive. Now we can execute the same using weighted distance KNN algorithm. Now I want to use here the weighted distance KNN algorithm. Just a minute, student. Here actually we did not build the model using here my classifier is the object for the weighted distance, and also for simple KNN classifier. This is actually the result of your weighted distance KNN. This is the result of weighted distance KNN. Right? Now we can see here we need to build model again for the simple KNN here. Here is the predict method. Before that, we need to create the object of this classifier. So if you copy this code again and build this simple KNN model, right? Your model will be ready here with this simple KNN method. Now I want to use this model to predict the class of my general KNN. Right? Now Y predict will have the predicted class of the complete whole data set that we want to display here. So if you run this code, you can find here the result of the general KNN. This is result of the weighted KNN. So you can compare this result, student. This is weighted distance KNN result. This is general KNN method. So you can find out which is correct and which is wrong. So here negative, negative. My general KNN is predicting negative, and weighted KNN also predicting negative. Here general KNN negative, here also negative. Here it is negative, but here it is positive. But my correct class is positive. How you will check this correct class? My y is the variable which contains my actual class label. So you can compare this predicted class with this actual class label. So my for the third data point, my actual class is positive. Here my weighted KNN is predicting correct result, but my general KNN is predicting wrong result, which is negative. Similarly, here fourth point is negative. My general KNN is predicting wrong result, which is positive, but here weighted KNN has predicted correct result, right? So two wrong classified records are there. Then next is here negative here, but my general KNN is predicting positive, but my weighted KNN has given the correct result, right? So here it is positive, here it is negative, here it is positive. If you observe, student, my general KNN has predicted this last 4 record wrongly. So see, my accuracy of this model is very, very low. If you calculate the accuracy score, right? Accuracy score for this model, how you calculate the accuracy score? By importing the accuracy underscore score functions from the model. So if you try here, accuracy score for this general KNN model, right? From Sklearn dot metrics import accuracy underscore score. The spelling should be correct, otherwise you will get the error. Also you can display confusion matrix, right? So if you run this, it is successfully run, means there is no error, right? Now you can find the accuracy score here. So how you can find out this? Why it is not defined under the classifier object, right? So here my statement should be this. Only instead of y test, I will pass here y. Okay. So print tester accuracy score y, y prediction. So if you run this code, you will find what? Unexpected end of file. One more. So if you observe here, student, my accuracy is only 33%. And if you display confusion matrix here, you will find 4 records are wrongly predicted. 4 records are wrongly predicted. So see, 2 and 0, only 2 records are correctly classified, right? And these two are false positive and 2 are false negative, and that's why my accuracy is very less for the general classifier, right? And if you execute this weighted model again, I want to run this weighted model, and we'll use the another variable here for the weighted distance classifier. I am using classifier 1 here, right? Okay, we have actually changed here the object of the weighted distance. Classifier 1 should be there, right? So again, I am running this. Here also we need to use 1, right? So now we have created the proper object here. We are using the proper object to create the y prediction, right? Now you can execute again this, and we'll see the result of this. So if you observe student, we have displayed this new score using the weighted distance classifier. So my accuracy is 100%. And also if you execute again this confusion matrix, so 4 are correctly classified: positive, and true negative, and false you are 0 in the confusion matrix. I hope student you are clear with this. Thank you.